Ah, welcome, fine physics folk. Some people made it clear that they thought it would be helpful if they had another video to explain some of the other stuff that would be on next week's quiz. And I decided to put this together, and hopefully this too can help you study. We're going to go over the acceleration equation, the charts, and speeding up and slowing down. But a quick recap. Acceleration is defined as the change in velocity over time. That is the definition that I want you to know for acceleration, the change in velocity over time. It is measured in meters per second squared. That is the unit for acceleration, but you already knew that. And I want you to know that there's three ways of having an acceleration. You can either speed up, slow down, or change direction, because those are the three ways you could change your velocity, and if you change your velocity, you have an acceleration. So I want to be clear on how to do the simple acceleration equations. These are the equations that we are solving for the acceleration. We do not really solve for the acceleration with any other equation. So if you see an equation that says, what was the acceleration, or what was its acceleration, we should be thinking about the acceleration equation. And that's A equals final velocity minus initial velocity divided by the time. Acceleration equals final velocity minus initial velocity divided by the time. That's what we're using here. So if you ever see an equation that says, a question that says, what was its acceleration, or what is the acceleration? This is the equation we're using. This is our only equation for acceleration as of right now, and this is the one we will use. Therefore, let's look at this problem. A bus was driving 14 meters per second, that's a velocity, positive meters per second, and after 8 seconds, okay, that's a time, it ends up moving plus 30 meters per second. So what we have to do is, after we read the question, we have to figure out what was the final or ending velocity, or what was the initial or starting velocity. Well, the word ends up moving indicates an ending or final. So I'm just going to plug it in. Plus 30 minus the initial was indicates a starting, plus 14 divided by the time, which in this case is 8. Okay? 30 minus 14 equals 16 divided by 8 equals 2 meters per second squared. That's it. This is the subtract then divide equation. This one wasn't as bad as the others. A bus was driving plus 15 and ends up moving plus 3 meters per second after 4 seconds. What was its acceleration? So because it says what was its acceleration, we know we're going to use the acceleration equals final velocity minus initial velocity divided by the time. Okay? So in this case, the final velocity, was that 15 or was that 3? Oh, ends up moving. That's final. So the final velocity is 3. Now, the reason why I'm going through this equation, this question, is because I want you to recognize it's not always the big number minus the small number. It's always final minus initial. So don't be worried if you get something like this. 3 minus 15 is negative 12 divided by 4 equals negative 3 meters per second squared. So subtract and divide. And if you have negatives, don't forget to keep flip change, or keep change. That's why I put them in parentheses. I put them in parentheses to make sure that we don't drop our signs. Oh, okay. A bus starts from rest and ends up moving plus 10 meters per second after 4 seconds. What was its acceleration? Okay, so if we're looking for acceleration, we know we're going to do final minus initial divided by time. It says ends up moving plus 10. Well, that's clearly the final. All right? Minus, what was the initial or the starting velocity? Oh, when I see from rest, that means it's 0. 10 minus 0 is 10. 10 divided by 4 is positive 2.5 meters per second squared. Okay, not too bad. A bus was driving plus 12 meters per second and ends up stopped after 6 seconds. What was its acceleration? All right, now this one's a little bit trickier. We're still going to do final velocity minus initial. It was driving 12. I think that's the initial. Was tends to indicate an initial or starting velocity. And ends up stopped. If I say ends up stopped, oh, that means the final velocity is 0. And we're going to subtract the initial velocity of 12. And then divide it by the time of 6. Final minus initial divided by time. Oh, 0 minus 12 is negative 12 divided by 6. Negative 2 meters per second squared. Now this one's tricky because there's no negatives anywhere in this question. But you have to know that you will do the final velocity of 0 minus the initial velocity of 12 to get a negative anyway. So this is tricky, but reading it carefully will help you out. And because it says what was the acceleration, we knew this was going to be the equation, so we knew there had to be 2 velocities. You've got to recognize the words ends up stopped. Nice. Now, this acceleration can work in the charts as well. Acceleration, don't forget, is defined as the change in velocity over time. So if I have a chart that has an acceleration of positive 4, what that means is that every single time I go over a box, I'm going to add 4, plus 4, plus 8, plus 12, plus 16, plus 20, plus 24. That's it. That's what this means. The acceleration is the change in velocity over time. So every second, that's how much the velocity changes. And it can be negative as well. It just means now that instead of changing by a positive number, you can change by a negative number. So if the acceleration here is negative 3, it should be 0, negative 3, negative 6, negative 9, negative 12. I'll just keep going, negative 3. I'm just keep going, negative 3. Okay? But you don't always have to start from 0. And in fact, you will often not start from 0. So what if you have this? Look at this chart. The acceleration is plus 5. I know that here the velocity is plus 11. So I know that every time I go to the right, I'm going to add 5. So this is going to become 16, 21, 26, 31. I just kept plus 5, and so on. Plus 5, plus 5, plus 5, plus 5. But if I want to go backwards, and I want to fill in these other missing blocks over here, and I do, to go backwards, instead of plus 5, you're going to have to minus 5. You have to use the opposite sign. So this would be 6, and then minus 5 again, and this would be 1. So what I'm saying is, when you go to the right on these charts, you use the sign that they give you. If you go to the left on these charts, you're going to use the opposite sign. So let's see how this is going to work here. Here I have plus 3, and it's saying that the acceleration is negative 2. So if this is plus 3 and the acceleration is -2, this is going to become -2, so that becomes +1. -2, this becomes -1. -2, this becomes -3. Okay? So when I go to the right, I go -2. But if I go to the left, I have to use the opposite sign. The opposite sign of -2 would be +2. So this is going to become +5. This is going to become +7. This is going to become +9. So if you go to the right, you use the same sign. If you go to the left, you use the opposite. That's all that's happening here. That's all that's happening here. Oh, okay. Well, what do I do if I don't have the acceleration at all? Well, acceleration is the change in velocity. So if I have two numbers right next to each other, how much are they changing? Well, 12 minus 9 equals 3. You always do the final, the right minus the initial, left, right minus left. Oh, so it's changing by 3. So that means the acceleration is plus 3 meters per second squared. So plus 3, so that's 15, 18, 21. And then when we go backwards, it's going to be minus 3. So this is going to become 6 and 3. So to get the acceleration, when you have two numbers next to each other, you just subtract the numbers, the right minus the left, and that would give you the acceleration. And then that plus 3 you use to solve for everything else. Okay. What about this? I said right minus left, so I'm going to do 9 minus 16. Well, 9 minus 16 is -7. Oh, -7 meters per second squared. So I'm going to just keep going, -7. 9 minus 7 is 2, -7, -5, -7, -7. That's it. That's all you do. And then I get this last box, +7. Because when you go backwards, you use the opposite sign. So you subtract the right number from the left number when they're right next to each other. But what if they're not right next to each other? What if we have a number here and a number here, and they're all the way apart? You are still going to do the right number, 40 minus 12. Right minus left. 40 minus 12 is 28. But now we have to divide it by the time. How much time happens between 1 and 5 seconds? 1, 2, 3, 4. There's 4 seconds between 1 and 5. So you count the jumps between your seconds. You count the jumps between your seconds. And there are 4 jumps between 1 and 5 seconds. Oh, 28 divided by 4 is +7. So the acceleration here is +7. Well, let's see if that's right. 12 plus 7 is 19. 19 plus 7 is 26. 26 plus 7 is 33. 33 plus 7 is 40. 40 plus 7 is 47. And then to get the very last here, we're going to minus 7. 12 minus 7 is 5. Okay, Bizzuto, I didn't quite get it that last time. Can you go over another one? Sure thing. I got 2 numbers. I am going to do right number, which is the -18, minus the left number. And I'm going to divide that by the time between where they start. So what is that, 6? No, it's not 6. It's the jumps from 3 to 6. 1, 2, 3. There are 3 jumps from 3 to 6, so I'm going to divide it by 3. Well, what is negative 18 minus negative 12? Oh, geez, I think it's negative 6. Do some keep flip changes going on, or keep change. Negative 6 divided by 3. Oh, that's negative 2. Oh, so the acceleration here is negative 2 meters per second squared. So when I go to the right, it's going to be negative 2. So if this is negative 12, negative 14, negative 16, good, negative 18. And when I go the opposite way, it's going to be plus 2, negative 10, negative 8, negative 6. Final velocity minus the initial velocity divided by the time. Okay. I want to see more of these because these aren't easy. I agree. Right minus left. 18 minus 4. Divided by, well, how many jumps does it take to go from 2 to 6? 1, 2, 3, 4. 4 jumps. 18 minus 4 is 14. 14 divided by 4 is 3.5. Just add a space. But that means the acceleration is 3.5 meters per second squared, positive. Really? Does that even make sense? Can you have a decimal? You sure can. 4 plus 3.5 is going to be 7.5. This is going to be 11. And then this is going to be 14.5 and 18. Nice. And then I go left, and then I'm going to minus 3.5. So this is going to become 0.5, and then it's become negative 3. Nice. All right. What about this? Okay. Final is negative 12 minus the initial is positive 12. Negative 12 minus positive 12 is negative 24. And how many jumps is it? 1, 2, 3, 4, 5, 6. 6 seconds to go from 0 to 6. So negative 24 divided by 6 is let's see if that's negative 4. Let's see how this works out. 12 minus 4 is going to be 8. 4, 0, negative 4, negative 8. Look at that. Nice. So that was the charts. That was the equation. The last thing I want to go through is the speed up or the slow down. How can you tell if something is speeding up or slowing down? Well, when I look at this, we're only looking at the rows. This is the initial velocity. This is the final velocity. So the trick, you guys, the trick is to not look at the positive or the negative and just to look at the numbers. Pretend the positives and the negatives aren't even there. Pretend they're not there. If you start going 12 and you end up going 18, is your number getting bigger or smaller? It's getting bigger, so you're speeding up. If you go from 20 to 5, your number is getting smaller. You're going down. Slowing down. If you start from 0 and you end at 5, you're speeding up. Okay, those ones are pretty simple. It's when you have the negatives that people tend to make mistakes. If you start from negative 10 and you go to 0, I know that negative 10 is a smaller number according to math. But in physics, negative just means left. So if you're going from negative 10, think about it. You're going from I said ignore the signs. What you're really doing is you're going from 10 left to 0. You're going from 10 to 0. So you're slowing down there. What, Pizzuto? Pretend the signs aren't there. You're going from 0 to -5. How about I say you're going from 0 to 5 meters per second left? Oh, you went from 0 to 5. So you sped up. Pretend the signs aren't there. Pretend they're not there. You're going from 2 to 12. Well, you're speeding up. You're going from 30 to 20. Well, you're slowing down. Pretend the signs aren't there. That's the key. And then if the number gets bigger, it's speeding up. If the number gets smaller, it's slowing down. Pretend the signs aren't there. And that's it. This is really all you need to know with the other video for our quiz next week. Best of luck.